Hello and welcome to the channel of TKG physics classes, and good night to all of you students. So students, in this video we are going to discussing about an important topic which is named as connected motion, and we will solve some numericals which is named free body diagram problem. Is very important problem for your board exam as well as for your competitive exam. All of you know, in competitive exam most of the question taken from laws of motion are related to connected motion or free body diagram. So this video is very important, students, for solving connected motion problem or free body diagram problem. So first of all, here you have to know the meaning of connected motion. What is the meaning of connected motion? You see this one figure. Here two bodies, 1 and 2 are connected. You know the name connected motion. As the name suggests, connected, that means the number of bodies are connected with one another. Connected with one another with the help of rope, with the help of string. These types of motion is known as connected motion. So you see here one body of mass m, another body of mass m, both are connected by a rope or you can say by a string. Now here if we apply a force capital F along this direction, the mass of this body is moving under motion condition. Now as this body is moving, this body is connected with another body, so this body is also in under motion condition. These types of motion is known as connected motion. You see another example. Here two bodies, both are mass m, or you can say this one is a higher body of mass capital 2m, and this one is mass m. Both are connected not by a string or by a rope, both are connected with one another, and here force capital F applying along this direction. So obviously this body is under motion as well as the body of mass 2m is also in under motion because both are connected. This is an also example of connected motion. Now see third one, pulley problem. You see with the help of support there is a pulley, and in pulley with the help of a rope there is a body of mass m, and on the other side there is a body of mass capital M. Both two bodies small m and capital M are connected with the help of a single rope, with the help of a pulley. Now here this motion is also an example of connected motion because two bodies are connected with the help of a rope and with the support of pulley. Now question is, for solving these types of problem, for solving connected motion, at first you have to know the basic thing. That means you see when there is a body of mass m, suppose, is placed on a horizontal surface, first of all of you know the weight of the body is directed always, the weight of the body is directed always vertically downward, and weight, that means mass into acceleration due to gravity. Okay, so the weight of the body which is always directed downward. Now this body, if I use this body is placed here. Now the weight of this body is directed vertically downward, but with the help of this direction, with the help of this magnitude value of force, the body is under rest, not moving in the downward direction. Question is why? Because is exactly opposite direction there is a force which is exactly opposite to the weight. So this force is named as normal reaction force. You see, so this is the force which is named as normal reaction force, or you can write N or capital R. This normal reaction force is always perpendicular to the surface. Write it down. Is always perpendicular to the surface. This normal reaction force perpendicular to the surface, and the weight of the body is always directed vertically downward. Suppose the body is placed in the inclined plane. Suppose body is placed like this way. Body is placed like this way, inclined plane. This angle is theta. So here also the weight of the body is directed W, that is equal to mg, vertically downward. But you know the direction of normal reaction force. Normal reaction force is directed perpendicular. This is the surface. So normal reaction force is directed perpendicular to the surface, N or R. always normal reaction force is perpendicular to the surface and weight is vertically downward. So this is the basic concept. Now in case of rope or string, you see our third condition, this one, there is a string with the help of support, there is a mass of M and there is another mass of capital M. Now in that condition we have to introduce another force which is named as tension force. Write it, tension force, which is named as the symbol capital T, tension force. Now tension force is always directed, the direction of tension force is always away from the point, away from the object. Mind it, very important students. So write it, is always directed away from the point. Suppose here mass small m, that means the weight W, that is equal to m into g, which is directed vertically downward, right? Okay, now this weight is directed vertically downward, so here there is an upward direction force for this mass, and this upward direction force is named tension force. You see, tension force for this body, that means the tension force, you see the direction always away from the point, so the body of tension force for this body, that is away from the point. Similarly for this body, weight W, that is equal to capital M into G, is directed vertically downward. Now here also tension force for this body is directed along this direction. And why both are named as T, string or rope same, that means tension same. Rope or string change, tension change. Mind it. So write down our second point, that is when string same, string or rope same, that means tension force name same, tension same. String different, string or rope different, you can write rope also, rope different, tension force name will be different, tension force different. So this is the concept. Here same string, you see same string are connected, two bodies, so here tension force both are named as T. Now see, we will apply tension force for this pulley also. Now for this pulley tension force, this pulley tension force is directed in this direction. You see, basic concept, always away from the point. For pulley, that is directed downward, always away from the point. Here point, that means pulley, you are calculating tension for this pulley. Now in that side, this one will be always away from the point, and here this tension will be different, not T. Why? Because the string are different. So suppose this is named as T dash. So here T dash is balanced with T plus T, and here you have to measure, suppose this one is moving upward direction and this one is moving downward direction. Now you have to apply free body diagram for solving acceleration, or you can say tension. Okay, so the basic concept, how we will apply free body diagram. For applying free body diagram, we have to consider three important points. Write it. So for free body diagram, that is FBD, write it down. So for free body diagram, free body diagram, that is FBD, we have to remember three important points, students. First point, we have to consider body or object. We have to consider body as a point object, as a, sorry, this is not writing well, as a point object. First point. Now second point, for free body diagram, we have to consider the forces, all the forces which is acting on body, acting on it, not forces by the body. So write it. We have to consider all the forces which is acting on it, or you can say body. And third point, write it. We have to consider a reference frame. We have to consider a reference frame. In most of the cases, in most of the problem, we consider ground as a reference frame. In most of the problem, we consider ground as a reference frame. Okay, this is named as inertial frame. So this is the basic concept. You have to always remember these three concepts for solving free body diagram. Now see, for this case you make a free body. At first, this body you have to consider at a point object of mass capital M. Now see here, weight W, that is equal to m into g, which is directed vertically downward, and here tension force capital T, which is directed vertically upward. Tension force capital T, which is directed vertically upward. Now, and the body is moving downward direction with an acceleration A. So what is the net force? Write it. Net force here. Body is moving vertically downward. That means obviously the weight m into g is more than tension force. So here net force, that means mg minus of t. Suppose this force is direct value, that is 10 Newton, and tension force, that is 6 Newton. So the net force, that means 10 minus 6. So in that way you have to write the net force, that means here mg minus of t, right? And net force, that means you use mass into acceleration. Mass into acceleration for this body mass is capital M, so mass capital M and acceleration A. In this way we will solve free body diagram. Okay, now let's take one real problem. Okay, you see this diagram. So first of all, write down. You can take a screenshot. Here a pulley, with the help of a pulley there is a two body of mass small m and capital M. You see there is a body of mass small m and there is another body of mass capital M are connected. Now suppose this body is moving upward direction and this body is moving in the downward direction with a common acceleration A. Okay, strings and acceleration are same. Now, so first of all, the weight W, that is equal to m into g, is directed vertically downward. Most of the cases, in most of the cases here you have to find out the value of acceleration and the value of tension. So in this problem we will find out what is the value of acceleration, what is the expression for finding A, and we will find out what is the expression for finding tension. Okay, so first of all, for this body weight W equal to mg, which is directed vertically downward, and here tension force is directed away from this object. Okay, now for this case also weight capital M into G is also directed vertically downward, and there is a tension force which is directed away from the object. This is the tension force for this body, and the tension force is always directed away from the object. Okay, now we have to solve the expression of A. What is the expression of A? So first of all, for solving expression you have to solve the free body diagram for this object as well as free body diagram for this object. Okay, so for first case, suppose free body diagram for this object. So you see this is a point object of mass m. You have to consider this is a point object of mass m. So weight W equal to mg, which is directed downward, and here tension force is directed upward, and this body is moving. Suppose this value is given capital M is more than small m. So this is the heavier mass. This body is moving downward, and so this body will moving upward. So this body is moving with an acceleration A in the downward direction. Now you see, mg in the downward, tension T is the upward, and the body is moving downward. So the net force on body capital M, write it down. The net force on body capital M, net force, that is equal to, obviously this force will be more, that's why the body is moving in the downward direction. So the net force, that means mg minus of T, and in the place of F you have to use the force of this body, that is capital M into A. So this is the expression. Suppose this is equation 1. This is the free body diagram and the free body expression for body of mass capital M. Okay, now you consider for this body. So point object of mass small m, W, that is equal to mg, which is directed downward, and there is upward direction which is named as tension force, and the body is moving with an acceleration A in the upward direction. So the net force on body small m, obviously this value will be F equal to, so here net force, that means T minus of mg, because the body is moving in the upward direction, so that's why T is more than mg. Okay, so write it, T minus of m into g, and here what is the value of F? Not capital M into A. This is the value of F for our body, which is mass small m. So F equal to small m into A, that is equal to T minus of mg. Suppose this is equation number 2. Now solve equation number 1 and 2 and find the expression of A and T. Okay, suppose we are adding equation 1 and 2. First of all, add it. So by adding equation 1 and 2, what will be the value? Write it. So by adding equation 1 and 2, we can write, adding 1 and 2. You see, MA, that means A common, small m plus capital M, that is equal to, here mg minus T, and there is T minus of small mg plus of T minus of small mg. So from here you can write, see, A small m plus capital M, and here plus T minus T cancel out, G common, so this value will be capital M minus small m. So from here you can easily write A, that is equal to capital M minus small m, divided by this one will be capital M plus small m with multiple of G. So this is the expression of acceleration. Okay, so you see there is upper part M minus M and there is lower part M plus M. So obviously this ratio is less than 1, because this is the less, M minus M is less than M plus M. So this value is less than 1. So we can write A is less than G. That is acceleration. Two bodies, the acceleration of two bodies is less than acceleration due to gravity. Okay, now we will find out the tension expression. How? Okay, divide this equation 1 by equation 2, divide it. So now dividing equation 1 by equation 2, that is MA divided by MA, that is equal to mg minus of T, and here T minus of mg. So AA cancel out. So from here you can write, you see, M into T, that is capital MT minus M mg, that is small m capital Mg, that is equal to, here capital M small mg minus of small m into T, small m into T. So now simplify it. You have to find out T. So you take MT left hand side. So this one will be T common. small m plus capital M, and you take this value in the right hand side, so this one will be 2 small m capital M into G. So from here T is equal to 2 small m capital M divided by small m capital M multiple of G. So this is the expression of tension force, tension. Okay, now in problem suppose m1 and m2 given, so you can easily find out what is the value of acceleration and what is the value of tension. Okay, so this is the theoretical part. Now we will solve some problems related to free body diagram. Okay, so solve it. See problem 1. At first write down figure given. Here three bodies m1, m2 and m3 are connected with the help of rope. Okay, with the help of rope they are connected, and here in the right side direction force applied, that is 50 Newton. Now you have to find out m1 value, m2 value, m3 value given. You have to find out the value of T1 and T2, that is you have to find out tension. Okay, you see here this rope for tension for m3 which is directed away from the body, that is value T2. Tension for m2 is directed away. See here this body, problem 1, this mass m1, tension for m1, that is which is named as T1, you see, and the direction of tension, that is away from the point, so tension for m1, that is away, and here body m2, this is the body m2, and tension for m2 same rope, so tension value will be same, so tension for m2 that is away from the point, so for m2 tension which value given is also T1. Now in same way here tension for m2 in that direction, that is named as T2, not T1. Why? String or rope change. Here rope change, this is one rope, this is another rope, so it is named as T2. And here that is body m3, and for m3 body tension away from the point which is named as also T2, same name because the string same, and in right side direction force given F 50 Newton. Now you have to solve, find out the value of T1 and T2. So first of all you find out the value of acceleration. Here you know force F is equal to mass into acceleration. Here force M is equal to m1 plus m2 plus m3 into A, because with the help of this force both the bodies under motion condition. So here F value that is given 50, m1 given you see 5 plus m2 that is 10 and m3 that is 15, that is A. So from here you can write A is equal to 50 divided by 30, that is 5 by 3 meter per second square. So this is a fast part. You have to find out acceleration. Now for finding T1 you consider free body. For this case you see body m1, and for m1 here tension that is T1, you see here tension T1, and there is no backward force, you see there is no backward force, and the body is moving in the right side, the body is moving with acceleration in the right side direction. So obviously this force which is named as T1 is the net force here, because there is no backward force. With the help of T1 the body is moving in the forward direction, so here net force F that is equal to T1, and this F not the value of the F here, not the value of 50 Newton. Here F that means the force for body mass m1, so F that means m1 into A that is equal to T1, not m1 plus m2 plus m3. So m1 into A that is equal to T1. So from here you can write T1 that is equal to the value of m1 5 and A 5 by 3, that is 25 by 3, that means near about 8.33 Newton. So the value of T1 8.33 Newton. Okay. Now second one, for finding T2 you can consider this body, free body for m3, and you can consider also free body for m2. Okay, I am considering for m2. You see here m2, right side direction tension T2, left side direction tension T1, and the body is moving in the forward direction. Okay, so obviously net force, that means T2 minus of T1, that's why the body is moving in the forward direction. So here write it, net force F, that is equal to T2 minus of T1, and you have to find out the value of T2. You know the value of T1, you know the value of F. Here F, that means not 50 Newton, F, that means the force for this body M2. So the value of F will be M2A T2 minus of T1. So from here you can write T2, that is equal to T1 plus of M2A. And what is the value of T1? 25 by 3. 25 by 3. What is the value of M2? That is 10. What is the value of A? 5 by 3. So this one will be 20 by 3 plus 50 by 3. So this value will be 20 by 3 plus 50 by 3. So T2 will be 75 divided by 3. Yes, yes. So this one will be T2 is equal to, what is the value? You see, 2, 1, 5, 25 Newton. Okay, so this is the value of T2. In this way you can solve free body diagram. Okay, now see problem 2. Okay, so in problem 2, at first write down the problem. Question given, 3 bodies are connected and there is a vertical, this is the horizontal case, this is the vertical case. Within the body's whole system is moving with an acceleration A, and you have to find out the tension, that is T1, T2 and T3. First case, when the whole system is moving in the forward direction, in the upward direction with acceleration A, that is 20 meters per second, and secondly when the whole system is at stationary. Okay, you see, for the total system in the upward direction the tension name is T1, and in the downward direction for M3 weight, that is M3G in the downward direction, for M2 weight which is M2G which is also downward direction, and for M1 that is M1G which is also downward direction. So here downward direction force, that is M3G, M2G, M1G, and upward direction force, that is T1. So the net force when the whole system is moving in the upward direction with an acceleration A, so obviously net force, that means T1 minus of this value, addition of this value. So T1 minus of, you see, M1 plus of M2 plus of M3G, that is equal to net force F. Why this one is addition? Because both the forces are directed in the downward direction. So here you have to find out T1. So T1, that is equal to M1 plus M2 plus M3G, and what is the value of F? Net force. Here F, that you are considering total system. So the F value, that is also M1 plus M2 plus M3 into A. F, that is mass into acceleration. You are considering the total system. So mass, that means M1 plus M2 plus M3, and acceleration, that is A. So the value of T1, that is, you take a common M1 plus M2 plus M3, and there is, if we common this one, A plus G. Now putting the value, so T1 is equal to M1 value given, what is the value M1? Yes, 5, M2 that is 2, M3 that is 3, and value of A 2, value of G 9, sorry, this value is 9.8. So this one is 10 and this one is 11.8. So this answer is 118 Newton. So this is the value of T1 for first case. You see, when the system is going upward with an acceleration 2 meters per second. Same when the whole system is stationary, the system is not moving, whole system is stationary, that means T1 is exactly equal to this value M1 plus M2 plus M3 into G. That's why the system is stationary. So for second case you have to use same thing, T1 minus M1 plus M2 plus M3G, that is equal to 0, net force 0, because the system is stationary. So you can easily find out the T1 that is equal to M1 plus M2 plus M3 into G. Now you just putting the value of M1 plus M2 and M3G. So this total value M1 plus M2 plus M3, that is 10, and G, that is 9.8. So this answer will be 98 Newton. So this is the answer for second case. Okay, so the value of T1 for first case, that is 118, and value of T1 for second case, that is 98. Now we will find out the value of T2. So for finding value of T2, we will consider this diagram. You see, okay, I can remove this part. Yes, for T2, you see, this is body of mass M2 and this body of mass M3. Here that is T3 and here this is T2. We are considering this part only, not M1. Okay, now you see here T2 in the upward direction and M3G and M2G in the downward direction, and the system is moving in the upward first case. So in that condition we can write, you see, this one will be T2 minus of not M1 plus M2 plus M3, here M2 and M3, so this one will be M2 plus M3 into G, that is equal to net force F. There is M1 which is missing here. Okay, now what is the value of T2? So T2 is equal to, you see, M2 plus M3G plus F. And what is F here? F, that means mass into acceleration. Here mass, that means M3 plus of M2 and acceleration A. So this value will be T2, that is equal to M2 plus M3 into G, and this value mass, that is M2 plus M3 and acceleration A. So if we take a common, that is T2 is equal to M2 plus of M3 common, so this one will be A plus G. Now just putting the value, so T2 will be M2 value given 2, M3 that is 3, that is acceleration 2, and G 9.8, that is 5 into 11.8, so 55 and 5, 8, 4, so this one will be yes, 59 Newton. So this is the value of T2 for first case. Now you see, for second case, when the system is stationary, the net force 0. That means this value T2 minus of M2 plus M3 into G, that is equal to 0. System stationary. When system stationary? When both the forces are equal and opposite. Suppose one force is directed here, and that is M2 plus M3 into G, and another force, that is T2 in the upward direction. System stationary, that means T2 must be equal to this one. So for second case, T2 is equal to M2 plus M3 into G. So M2 plus M3, that is 5, and G, that is 9.8. So this answer will be, you see, 45 and this is 4, that is 49 Newton. Yes. So in second case, the value of T2, that is 49 Newton. In same way, you can find out the value of T3 also. For finding T3, you just consider this figure. You see, this is M3 and in the upward direction there is T3. So for third case, write it. For third case, the net force, that is T3 minus only mass M3, so weight M3 into G, which is downward, and T3 upward, and system is moving upward, so net force T3 minus M3G, that is the net force F. So T3 minus M3G net force, that means M3 into A. Here mass only M3 present, so T3, that is equal to M3 common, A plus of G. So T3, that is equal to value of M3, you see 3 kg, 3, this one is 2 plus 9.8, that is 3 into 11.8, 33, and this one is 24, that is 35.4 Newton. Yes. And for second case, T3 will be the net force F0, system is stationary, that means T3 must be equal to M3G. So T3 is equal to M3G, so M3 3 and G, that is 9.8, so this one is 27, 3, 8, 24, so this one is 29.4 Newton. Okay, so this is the basic concept as important for your competitive exam. Now go back to your exercise book and solve these types of problem. If there is any problem, tell me in the comment section. Today I'm ending here. Meet you in the next class. Bye bye.